Radio wave imaging is a safe technology that lets us see through solid objects like walls or closets. It works by sending out low-energy waves that bounce off hidden objects to create a digital picture. Unlike X-ray, radio waves use non-ionizing radiation. This means they don't have enough energy to alter cells or damage human tissue, making them completely safe for everyday use. We use this technology for airport security scanners, medical imaging, and finding hidden parts inside walls. It is a powerful, harmless tool that helps us safely see the answer. What are electromagnetic waves? They are like tiny packets of energy, like photons, moving at the speed of light. Even though they have no weight, they carry enough punch to move things and transmit data. They are made of two parts, an electric field and a magnetic field working together. They vibrate back and forth in signs to keep the wave moving forward. Electromagnetic waves come in many sizes. This includes everything from the long radio waves that carry music to your car to visible light that you see with your eyes. Unlike sound wave or ocean wave, electromagnetic wave can travel through the emptiness of space. This is why light from distant stars can reach the three types of wave from the image. First, radio wave is the longest wave. They pass through walls easily and send signals over long distance using antennas. Second is the microwave. It's a shorter and higher frequency wave. They power your Wi-Fi, connect to satellites, and heat up food. The last is millimeter wave. It's a tiny and higher power wave. They are used in airport security scanners to see through clothing without using harmful X. Here is the simple breakdown of how these radio wave images are created. First, send. A device shoots off a quiet pulse of invisible radio wave, like a flash of light. Second, pass. This wave travels easily through soft materials, like your closets or thin walls. Third, bounce. When the wave hits something solid or high-thin, like a metal object or a person, they echo and bounce back. Fourth, catch. Sensor action like ears that listen for and catch thus return anchors. Fifth, map. A computer looks at how long the anchors took to come back and turns that data into a clear 3D picture.
What is GPR? Ground Penetrating Radar or GPR is a non-destructive geophysical technique used to investigate and map features beneath the ground surface. It uses high-frequency electromagnetic waves to detect buried objects, underground utilities, voids, and changes in soil or rock layers. Because GPR does not require digging or drilling, it provides a fast and efficient way to examine surface conditions while minimizing damage to the area being surveyed. Next is, how does GPR works? GPR works by transmitting high-frequency radio wave into the ground. These waves reflect off buried objects and boundaries between different underground materials. The reflected signals are then recorded and processed to recreate an image of what lies beneath of the surface. This allows engineers and researchers to detect underground structures without excavation.
In this slide, we present the applications of ground penetrate radar, which is GPR. First, in road and bridge inspections, GPR is used to measure the thickness of pavement layers accurately. It can also detect hidden parts and damage beneath the surface. This helps engineers identify problems early and improve maintenance planning. In addition, GPR can locate steel reinforcement and assess moisture-related damage in bridge structure. Next, in archaeology and artifacts, GPR allows researchers to study underground features without excavations. It can locate buried walls, foundations, and also remains. It also helps map the layout of ancient site and detect hidden chambers or tunnels. This makes the excavation process more efficient and less disruptive. Moving on, in utility pipe and cable mapping, CPR is used to locate underground pipe, cables, and conduits accurately. It helps determine their depth and directions, and can also identify unknown and undocumented utility lines. This is very important in constructions as it prevents damage and improves safety during excavation. Finally, in geological and environmental study, GPR help detect underground features such as groundwater level and different soil level. It can also track contamination movement and identify sinkhole or weak zone before they become serious hazard.
Assalamualaikum, my name is DANISH and today I will be talking about magnetic resonance imaging. Magnetic resonance imaging, or for short MRI, is a non-invasive medical imaging technique that provides high-resolution 3D images of the body's internal structures, particularly soft tissues like the brain, muscles, and organs. Unlike X-rays or CT scans, MRI does not use harmful ionizing radiation. It utilizes strong magnetic fields and radio frequency pulses to generate signals from hydrogen. How does an MRI scan work? One of the factors is because of biological abundance. Humans are made of 60 to 70% water, which are H2O, and fat, both of which are rich in hydrogen atoms. MRI primarily targets the hydrogen nucleus, or a single proton, because of its high concentration and strong magnetic moment. The second factor is tiny magnets. The middle of these hydrogen atoms, or protons, act like tiny spinning compass needles. Usually, they point in all different directions. These are some of the images that you can see of what you can see how a hydrogen proton looks like because of the protons. Step 1. Alignment. Inside the MRI machine, there is a giant circular magnet. This magnet will align the randomly spinning hydrogen protons. To generate a signal, you must disturb the alignment. A radio frequency, or other pulse, is applied at a specific alarm frequency. You can see from the pictures given, some of the protons are not aligned because there is no magnetic field. When given a magnetic field, the protons will start aligning, but some of them will not align in the same position. Step 2. Energy pulse. The machine then sends a quick pulse of radio frequency waves, like a radio station signal. The pulse gives the hydrogen atoms energy, causing them to tip over and spin out of alignment. We can see from the picture given, when the radio frequency pulse is given, the hydrogen atoms will start aligning in the same direction following the radio frequency pulse. We will also see an animation given of how the hydrogen atoms. Step 3. The echo. The first part is listening. When the radio pulse is turned off, the atoms relax and snap back into line. Second part, signal. As they snap back, they release a tiny radio signal of their own frequency called an echo. Thirdly, mapping. A computer listens to these echoes and maps exactly where they came from. Lastly, the result. Because different tissues like fat, bone, and water snap back at different speeds, the computer can build a high detail map of your internal anatomy. This is one of the example pictures that I have taken from one of the MRI scans that can be found openly on the internet. Here we can see the person's MRI scan of the head. We can see the brains, the skull structure, the nose function, and the lips. You can see that the brains moves from the head to the entire body. That is all from me. Thank you.
Some advantages of MRI are its excellent image quality and the fact that it does not use ionizing radiation. However, MRI scans can be expensive, take a longer time to perform, and may not be suitable for patients with certain metal implants. Overall, MRI is an important medical imaging technology that supports accurate diagnosis and treatment. One major application is brain imaging, where MRI helps doctors diagnose conditions such as strokes, brain injuries, and neurological disorders. MRI is also widely used for tumor detection because it can clearly show the size and location of abnormal tissue growth. In addition, MRI is used to examine organs and soft tissues, including muscles, ligaments, and joints, helping doctors identify injuries and abnormalities. Next, I will discuss the applications of MRI or magnetic resonance imaging. MRI uses magnetic fields and radio waves to create detailed images of the body's internal structures.
Now, I will explain about millimeter wave scanners. Millimeter wave scanners are imaging systems that use high-frequency radio wave called millimeter wave to detect objects hidden under clothing. The scanner sends electromagnetic wave toward the body and analyzes the reflected signals to create an image. This allows security personnel to identify concealed items such as weapons or explosives. There are two types of millimeter wave scanning, which are active scanning and passive scanning. Active scanners emit millimeter wave signals and measure the reflected wave to form an image. This is the technology commonly used in airport security today. Passive scanners, on the other hand, didn't emit radiation. Instead, they detect the natural radiation emitted by the human body and surrounding environment. One important advantage of millimeter wave scanners is safety. These scanners use non-ionizing radiation, which means the energy is too low to damage human tissues or DNA. Therefore, they are considered safe for public use. In conclusion, GPR, MRI, and millimeter wave scanners all use electromagnetic wave for imaging purpose, but each technology has different applications. GPR is mainly used for underground detection, MRI is used in medical imaging, and millimeter wave scanners are used for security screening. Overall, radio wave imaging plays an important role in modern technology because it improves healthcare, safety, and infrastructure inspection through non-invasive and efficient imaging methods.